Okay, class, we're on problem number 7 in lesson 7 of chapter 5. The following table represents 6 different trips made by Fonzie on his motorcycle. What number or expression belongs in each of the blanks? So we have here the 6 trips. We have a column here of counting the number of trips or showing each line of each trip, right? So we have trips, and we're just going to go down 1, 2, 3, 4, 5, and 6. Now, we have the distance. Now, we don't know some. We have some, and we don't know others. So we're going to have to determine the distance for some of these. And in the first case, we do not know the distance here. We have 40 and 35. We have another unknown distance here. And we have 25. And of course, we're now going into algebra with the letter Z. Okay, the letter Z represents distance here. Now we also have a rate. And the distance was measured in miles. So I'm just going to put that over here. Miles with an M. Okay, the rate is in miles per hour. Now we have various rates here. We have 60. Excuse me, I didn't write that well. There's a 60. Then we have an unknown value here. Then we have 70. That 7 did not come out right. Actually, the 0, so there's 70. And we have 65. An unknown number here. And then we have 75. Now, I like this exercise because it's really going to put us to think what we're going to notice in each of these values, the relationships they have to one another, and this is going to help us to determine what our formula could be. Okay, we have distance, rate, and time. Let's just put in time, and time here we know is measured in hours. Okay, and let's put the time in. So we had here 0.25, and here we had 0.8, and we have an unknown, and here we have an X, and here we have a Y, and then again an unknown. Now we're told that that Fonzie made 6 different trips on his motorcycle. So one of the things that we're seeing here is that there are different numbers or different distances, different rates, and different times. So really each one here is independent of one another. But we do know that we can use the formulas that we've been given in, or the formula of distance is equal to the rate times the time. And in doing so, we should be able to determine what one or the other is. So plugging in the values here, if we were to put the distance, well, the distance we do not know, but we do have a rate, and we do have a time. All right, so if we were to take this and do our math, okay, we would know that for this particular answer, 60 times 0.25, do our math, the answer for the distance would be 15. Now, if we were to, and that was an easy one because we're determining distance is equal to rate times time. Now in this case, we actually have the distance, and that's going to be equal to the rate, which we do not know, times the time. All right, so let's just put the times 0.8. Now, for us to solve this, we would have to divide each side by 0.8, and that would give us r is equal to 40 divided by 0.8. And if we do our math there, we would know that the answer here would be 50. I'm not doing the math on the board. I think what's more important for you to know, you should be able to do this math, and if you use your calculator, it's much easier. But what I'm trying to show you here is the relationship of these numbers. We now have a distance of 35. And that's equal to the rate, 70, times the time, or 70t. We don't really need the dot, but in this case we just put it there to be consistent, but we can write 70t. Well, what would we do here to determine what the actual time is? We would divide each side. We're solving for the letter t, and again, if I were to write this over here, I would divide each side by 70, right? And 35 divided by 70 we know is 0.5. So let's just remove that, because again, we only have so much room on our board here. So let's put this as 0.5 would be our answer here, and that's the time. And again, he traveled 35 miles at a rate of 70 miles per hour. Well, if he would have gone a full hour, he would have gone 70 miles, right? But he only went 35 miles, which means he traveled, since it's half the rate, he went half the time, which would have been half an hour. Okay, now let's take a look at the trip number 4. Well, the distance we do not know, so distance is going to be equal to 65 times x, or 65x. And so for us to determine what the distance is, we would have to know the time. We don't know the variable, so we could just simply say d is equal to 65x. So 65x would actually be the answer here. All right, let's take a look now at number 5. We have 25 as a distance. We have a rate, an unknown rate, and we have y times y. Okay, so for us to determine the rate, we would have to divide each side by y, wouldn't we? So our answer, unfortunately, I'm not even going to try to fit into that box. I'll just write it over here. Our answer here is really 25 divided by y. And in our last problem, we have the distance of z is equal to 75 times time. Now, for us to determine what time is, we would divide each side by 75. And again, I'm going to end up with a fraction here. I'll just write it on the side. Z divided by 75. So this is how we were able to determine the missing factor or unit. And in some cases, these are going to be variables. And the variable in itself gives us an opportunity maybe to put in as many different values if we were determined, if we were given a chart or a table of numbers. But again, you see the relationship on this chart from distance, rate, and time, and how you can find either or depending upon what information you've been given.